This is the direction of G. How to calculate the field inside and outside the point. So one point, let it be inside, other point, let it be outside. First we'll go for calculation of field inside the wire, that one. So here I'll assume a so let there be a Amperian loop, radius of that, let it be R, radius of that E. So current enclosed, let it be I. How to calculate that I? So here I'm going to assume a strip that was uniform current distribution. Now it's a non-uniform current distribution. So let me assume a strip of radius R, width dr. How much of current enclosed in this? First we'll calculate di. So what should this area of this strip, or the area of this strip? dA is equal to 2 pi r dr. So what is di is equal to? Di should be equal to J into 2 pi r dr. Current density into area of the strip. Now what is the current density value? J naught r square. So 2 pi J naught r cube dr. This is di. How much of current is enclosed in a Amperian loop of radius? This is a loop. This is surface of wire. And here is what I'm going to choose, the DL. And this is B bar. So let me go for integration. Total current enclosed will be 2 pi J naught R cube dr, 0 to R. So this is a current enclosed by the Amperian loop. Then we'll write the equation. So this should be B1, I'll take it a point. B1 dot dl mu naught, current enclosed by Amperian loop is I. So everywhere B1 is parallel to dl and it's also constant. So B1 I'll take outside. Net current enclosed 2 pi J naught R to power of 4. Simplification of this will be 2 pi R mu naught 2 pi J naught. So what is the magnitude of magnetic field strength? Will be B1 is equal to 2 pi R will get cancel out, mu naught J naught R cube by 4. Oh, one, yeah, this 4 is here. This. Look at the magnitude now. Yes, it will be varying. At the axis, how much it will be? Exactly the axis will be 0. As you move away from axis, the field strength will increase and it will be concentric circles. Current will be perpendicular to that particular thing. So we have one vector relationship. Tomorrow I'll tell you, no? We have that R bar, B bar, and current density is also vector quantity. R is a position vector. B bar is a vector quantity. So all they're related by one vector relationship. So this is about the field inside the long wire. What about the field outside? This is inside the wire. How to calculate outside the wire? So we should find out now field inside the wire or at point P1. No, the point P2 lies outside the wire, and inside the wire the current density is varying radially. J equal to J naught R square, what we assumed it. So here I'm going to proceed like this. There's a y, no? So total current enclosed, I'll find out I, and the ampere in loop, I'm going to bring it outside. Now RBD will I. So what is DL? The DL will come here. I'll change the direction of arrow because we assumed anti-clockwise, no? Let me assume different. So current here will be in this direction. So what is DL? DL is here. DL is here. And B2 will come in at this point. And the point P2 is what? This one. But we don't know total current, only current density is there. So I'll take help of this formula. The limit I'll put 0 to A. What we have this integral of di 2 pi j naught r cube dr. This will be 0 to A. The total current enclosed or total current flowing through the wire will be 2 pi j naught a to power of 4 by 4 or pi j naught a square by 2. No. So what is the formula? B2 dot dl equal to mu naught. Net current enclosed is I. Everywhere B2 is parallel to dl. So closed path mu naught pi.
Sir, how did you get A square, sir?
A, oh, it should be a to power of 4. Sorry. To 2 it will be there. Check values. Integral r cube d cube a to power of 4 by 4, 2 by 4, 1 by 2. Yeah. So here a to power of 4. This should be 2. B2 2 pi r mu naught pi j naught a to power of 4 by 2. Pi get cancelled, so the final value will be mu naught pi j naught a to power of 4 by 4r. Now look at field outside. As you move away from wire, should decrease. As you move away from wire, the field strength will decrease. So whether the current flowing through a wire, the current density is uniform, non-uniform, or constant, or let it be variable. So what should be the field outside the wire? As you move away from the wire, the field strength will decrease. So current flowing through a wire can be like a current density can be constant or current density can be variable. So if the variable comes, use this one. So altogether now what is the you see that one. Can you use Biot-Savart law? No way, no. There's no other alternative. Like a field due to charged conductor. There's no other way. We must take help of Gauss law. Similarly, field inside the conductor. We must take help of the Ampere circuit law only. This is the advantage of that one. So theoretical part, there are two ways you can divide this problem. The conceptual part like flux, charge given, calculating flux. Similarly here, different types of current and loops will be given. Calculation of B bar dot DL. That's a one logical set of problem. The second set of problem is different types of current carrying structures, how to calculate the B bar. What is very important here? The loop, what you assume. The loop. And there's a wire. Pi will not be there. Huh? Yeah, okay, thank you. Yeah. Okay, these are about the introductory part. So we have to go for now the application of this. What all today I discussed, no? Just to say idea of Ampere circuit law. What is use of that? how it can be used for to calculate the field. So the major application is calculation of field only. The rest other things we define some theoretical higher ideas like magnetic pressure, all those things we can define with this one. Like as we went for conductor, electric pressure, how we define here also the magnetic pressure we can define further as we continue. So tomorrow we'll take furthermore few more applications. Okay, thank you all of you. Any doubts related to today's class you can clarify.
Sir, sir, mine is a very basic doubt, sir. I'm not able to find the direction of B bar, sir. Like,
Right hand thumb rule. So here what you should do is right hand thumb rule. So here hold the pen direction of current. So it'll be like this, no? The thumb will give direction of current. What about field here? Look at my fingers. Field here will be into the plane. And what about here? You look at the fingers again. So what about B bar here? So all let's do one thing. So take some, if they say, if this a wire is there, so let the wire be along north-south direction. And the current is flowing along south to north. Okay, I'm asking you now the field at this point. So what about the at a distance r? How the field here will be? The field here will be, this is upward. I think north south again will confuse. So let me take a ground. You are standing. Let me take a ground here. This one. So this is the north, east, north, south, east, west. And we have up and down also. Will I agree? Even up and down also will come. So this, what you can call up, this you can call down. Okay, now let's there be a current carrying wire. How it is parallel to the earth, parallel to the surface of the earth. Now, what about the field at this particular point? Lines of force. How the lines of force will be? The lines of force will be concentric circles. Now, what about the field at this point? B bar. So these are the arrows. So draw concentric circles and put thumb in the direction of that into cross mark. The fingers will swing like this. Now let's ask you a few questions. So what about the field at this particular point? Shall I say down? Down. What about field at this particular point too? Shall I say along east? North, south will not come into picture here. Up, down, west and east only will come. So the field at this point will be along east. What about the field at this point? Up. What about the field at this point? Will be along west. Getting the idea? Now instead of this, if the wire is like this, let's take this one. Now you are holding the wire in this way. How the lines of force? You are going to draw lines of force. What about the field at this particular point? No. You are going to say along north, no? Agreed. So what about field at this point? No. Two. Okay. No. I think okay. 12. Let me take. So you're going to say along the south. You have to draw a tangent there, no? That's all. And what about field here? Field here will be along east. Field here will be along the west. Up and down will not come here. So how this is? This is perpendicular to plane of the ground. The wire. Here what when the wire is parallel to the surface.